Okay, hello everybody, and thank you for letting me speak to you today. As I said in the introduction, my name is Geraint Lewis. I am a professor of astrophysics at the University of Sydney, and I work on lots and lots of different things, but one of my favorite topics is this area of astronomy that we call galactic cannibalism, which of course is something we should talk about on Halloween. So what I'm going to do today is I'm going to give you a brief overview of what galactic cannibalism is and what it tells us about the universe. So, of course, as a starting point, here we've just got a picture of the night sky. And this is the night sky as seen from South America. This is at the very large telescope, which is located in Chile. And what we have here, this is a part of the night sky which actually has in it what's known as our galactic center. So we know that we inhabit our local patch of the universe with roughly 200 billion other stars in an object that we call the Milky Way galaxy. And over the last few hundred years, astronomers have tried to pick apart the structure of the universe. Now, of course, astronomers were sort of famous for looking at the night sky. But if you're an astronomer like me, who's really a physicist deep down, we want to do more than just look at the night sky. We want to understand what it is that we're seeing. And over the last 100 years, we've learned that we live in a very exciting universe. One of the things that was discovered almost 100 years ago now is that we live in an expanding universe. So our universe isn't static, it changes over time. And what's happening is that galaxies, and we'll come to what they are in a moment, objects in the universe are moving further and further apart with time. We've also worked out that the universe had a beginning. So our universe hasn't been around forever, but it was born roughly 14 billion years ago in something that we call the Big Bang. And when it was born, we know that the universe was very hot and very dense and very unlike the universe we have around us today. And that universe, it was in those first few minutes that the first chemical elements were made. So it was a very different kind of universe to the one that we see today. But we have really good evidence about how the universe behaved in its earliest epochs because we see this leftover light on the sky. If your eyes could see microwaves instead of optical light, the entire sky would glow. And this is leftover radiation from the birth of the universe, which has cooled down and cooled down and cooled down, such that it's microwaves today. So astronomers have been able to look at the night sky and put together what the past history of the universe looks like. Now, in this next slide, which is slightly complicated, this represents the history of the universe as we understand it. On the left-hand side is the Big Bang, or the birth of the universe, and we don't really understand how the universe was born. This is still a big mystery to astronomy, and we're looking for bright young minds to come into astronomy to try and solve this problem. But soon after the universe was born, we knew that it was hot, it was very dense, and it was a very peculiar environment, nothing like the kind of environment we see in the universe today. Over time, though, as we move towards the right, the universe has expanded and it's cooled down. And what has happened in that time is that gravity has pulled things together. And then we got the first stars forming, and the first stars joined together to create galaxies. And we sit in this universe today, which is said was very unlike the universe as it was 13 billion years ago. So we've used the laws of physics to try and unravel the evolution of the universe, and it's been very, very successful. If we could step outside our Milky Way galaxy, this is what we would see. So the stars that we inhabit the universe with, they aren't just randomly scattered around, but they actually sit in a beautiful flat plane. And we can see there's this lovely spiral pattern. And our Milky Way galaxy, again, if we could look from the outside, would look like this kind of spiral. In that first picture we saw, when I said we were looking at the center of the galaxy, what we were looking at is that sort of yellow fuzzy area in the middle here. Our sun is located about 24,000 light years. So that's 24,000 times the distance light travels in 1 year, away from the center of the Milky Way galaxy. So we would be out in one of these spiral arms. So one of the big questions that we have as an astronomer is that the universe started off being hot and dense and effectively featureless. And today we have stars, again, I said around 200 billion stars in the Milky Way galaxy. How did this structure form? Where did this beautiful spiral structure come from? Now, we know that the Milky Way isn't alone in the universe, and there are lots of other galaxies out there. And in fact, when we look out into the universe, we can see that there's around 1 trillion other galaxies. And some are similar to the Milky Way, some are very different. So here we've just got a basic scattering of different kinds of galaxies. Some of them show the same kind of spiral patterns that we can see in the Milky Way. Others have less features, others are sort of more blobby. So there's a range of kind of galactic types. Now, I saw in the chat beforehand, people asked how big are galaxies. So what I've got now is a little movie that I pinched off YouTube that basically goes through the sizes of galaxies. So we're going to start small. That galaxy there with a few million stars is called Segway 2. And it's a few hundred light years across, so much smaller than our Milky Way. As we work our way up in size, we get to larger and larger galaxies. So this is Messier 32, about 6,500 light years across. The Small Magellanic Cloud, this is one we can see on the southern sky with our naked eye, 7,000 light years across. Triangulum, again, this is now starting to look a bit like our Milky Way, 60,000 light years across. So we're getting larger and larger, but you can see already that that first galaxy we looked at, that's already off the scale. It's just a tiny dot. Eventually, we get to the scale of our Milky Way galaxy, 100,000 light years across. But essentially what we see is that there's a whole range of different galaxy sizes. Some are very small, some are very big. The smallest galaxies are a tiny fraction the size of the Milky Way. The biggest galaxy is about 5,000 times larger. So there's a whole range of galaxies out there. Now, it turns out that galaxies are like animals, right? Bigger animals, they are rare. Smaller animals, they are very common. And so if we look out into the universe, if we look around our own Milky Way, so our Milky Way is in the center here, we see that the Milky Way is not alone, but is accompanied by a group of other smaller galaxies. So these are called dwarf galaxies. They're tiny little things, but they orbit the Milky Way. And over the last sort of 100 years or so, we've discovered that there are around 50 little galaxies that inhabit our patch of the universe with the Milky Way. Again, if we zoom out again, what we've got on the left here, there's our Milky Way galaxy. There's the lovely spiral. We can see that there's a small group of galaxies that live with us. Near us in the universe, about 2 million light years away, is the Andromeda galaxy. The Andromeda galaxy is about the same size as the Milky Way, and it's got its own little collection of dwarf galaxies. So again, as an astronomer, we want to say to ourselves, well, why does the universe look like this? Why is it this way and not some other way? Of course, as I mentioned at the start, when we look deep into the universe, we see that there are a lot of other galaxies out there. Our telescopes have estimated, right, that roughly there's 1 trillion galaxies that we can observe, and they are scattered through the universe. And when we look in detail, we see that the big galaxies have small galaxies, and galaxies tend to live together in groups and clumps. And again, the question is, why does the universe look this way? Now, one of the big successes we've had over the last 20 to 30 years is to answer this question. What we've been able to do is we've been able to generate our own universes. And what I mean by that is that we're able now to generate universes on computers. So we can take the laws of science as we understand them, we can translate them into computer code, and we can basically run a simulation of our universe on a computer to see how it evolves. Now, to do this with any accuracy, you need to have a very, very big simulation, and you've got to use an awful lot of sort of computer instructions to represent all of the complicated physics that goes on in the universe. But it's proven to be very, very successful. So I'm going to try and run this movie. Hopefully this movie will be happy running over Zoom. This is the result of a computer simulation that was done in Europe by a group called Illustris. What you're looking at here is a huge chunk of the universe, the synthetic universe, Our Milky Way galaxy, with its billions of stars, would be just one of the tiny dots that you can see. What you could see is going on here is that this is the universe evolving over time. So there's a little clock ticking away in the bottom left, and that is time since the Big Bang. And so this is 2.5 billion years after the Big Bang. You can already see that matter is being drawn together by gravity and clumping down into what becomes the first galaxies. Now, this simulation, this took roughly 5 years on a supercomputer to generate because they included so much physical detail. What we've got to now is that the first stars are burning, and the first stars were very massive, and they explode. And you can already see these shock waves coming out, and those shock waves are the shock waves from supernova, which are blasting material back out into the universe. Now, remember, as I said, our little galaxy would be one of these tiny little blue dots. And so we would imagine that our galaxy is going to be surrounded by all this other stuff going on in the universe. Now, one thing that we've discovered when we look at these simulations in detail and ask the question, how does a galaxy like our Milky Way form? Does it just sort of come out of all the sort of smooth background as one big galaxy, all evolved together? Or does it grow? And does it grow by basically gently having stuff raining down? Or does it grow via some other way? And what we've discovered is that a galaxy like our Milky Way started off relatively small, but it grew by eating other galaxies. What happens is small galaxies approach the Milky Way, and as they get too close, the gravity of the Milky Way galaxy tears the smaller galaxy apart and consumes its stars. So the Milky Way has grown by eating smaller systems. And this is something that we call galactic cannibalism. So hopefully again. So in this little movie we've got here, in the middle is our Milky Way galaxy, now seen edged on. What we've got going on is we've got 3 smaller galaxies which are orbiting, and they're getting too close. And you can see that every time they get close, they're getting stretched out and stretched out. And that stretching is due to the gravity of the Milky Way. Their stars are being ripped off, and their stars are being added to the overall galaxy. And essentially, galaxies grow by being bullies, right? As soon as you are the biggest bully in the playground, you bully all of the smaller objects, and you always win because your gravity is stronger. So our Milky Way is a cannibal, and it has been growing over billions of years by eating smaller systems. What does that actually mean for our galaxy as we see it? So if you could imagine that we could look out into the environment of our Milky Way galaxy, so our Milky Way would be hidden away in the center here, we would expect it to be surrounded by all of these streams. And these streams, these are little galaxies that have come too close. Their stars have been tugged by the gravity of our galaxy, and they have been pulled off, and we should be surrounded by these streams of galaxies which are currently being consumed. Now, we have found, as I mentioned, lots of little galaxies scattered around, and they are the food of the future. They are objects that are eventually going to fall in, and they will be consumed by the Milky Way. But what we should see right now are the signatures of small galaxies being eaten. And astronomers have gone hunting for them. This picture here, again, this is the center of the Milky Way galaxy, right? This is an older picture, and you can see that just below the center of the galaxy where you can see all that brightness, there is a squiggle that's been drawn. Now that squiggle was discovered in 1993, which I know is a long time ago for you guys because you're so young, but for me, it's not that long ago. This is an object that was discovered by a good friend of mine named Rodrigo Abata, and he discovered this during his PhD. And what he discovered is that on the sky, right near the center of the galaxy, is a little galaxy called the Sagittarius Dwarf galaxy. And it sat there undiscovered for, all the time we've been looking at the sky. And one of the reasons that we didn't know it was there is because it's so faint. It is very difficult to detect. but it's definitely a little dwarf galaxy. And straight away, when you look at this little object, you can see that it looks really ragged. And it looks ragged because it's being pulled apart by the Milky Way galaxy. In fact, we now know this galaxy is on the other side of the Milky Way, and it's moving upwards, and it's crashing into the disk of the Milky Way galaxy on the other side. But we know that in a few orbits, the gravity of the Milky Way is going to completely dismember this little galaxy, and its stars are going to be completely added to our own. One of the things that we've been able to learn is that the Sagittarius dwarf galaxy, when we actually look at not just the main body, but across the sky, we can see the telltale signs that it's being dismembered. We can see this big stream of stars, which is now known as the Sagittarius dwarf tidal stream. And it completely wraps our Milky Way galaxy in several wraps. And this wrapping means that the Sagittarius dwarf galaxy fell in several billion years ago. It's orbited around several times. And as it's orbited, its stars have been torn off and ripped apart. And we are consuming the Sagittarius dwarf galaxy. Now, this image, this is not just a single image taken with a telescope, but this is thousands of images all stitched together to produce a map of the sky. So this image was obtained in Apache Point in Arizona, which is an observatory. And they had a dedicated little telescope, and its sole job was to map the sky. So this entire image, this is like a huge swathe of the northern sky. And what they've done with this image is they've tried to map out the structures that we have in the halo of the Milky Way galaxy. How many streams of stars are there? And one of the things you can see straight away is the Sagittarius stream. That's that stream of stars that is coming off the Sagittarius dwarf and is completely wrapping our Milky Way. So that's some of the food that the Milky Way is consuming. You can also see that there's something called the orphan stream, which stretches across the sky in this direction. That again is another little dwarf galaxy that is being torn apart. So that little galaxy is being ripped apart. And in fact, it's being ripped apart so much that we can no longer find the dwarf galaxy and we only see the stream. And if you look over here, there's this beautiful object. This is called Palomar 5. And this isn't a dwarf galaxy. This is a slightly different object called a globular cluster. But you can see that it too has got a beautiful tidal stream and is being ripped apart. So as we have been able to survey the halo of the Milky Way with our telescopes, we are seeing the telltale sign is that our Milky Way galaxy is still a cannibal and is still consuming other objects. At the moment, there's a very powerful telescope which is surveying the southern sky. So this is the 4-meter telescope, which is located in Chile, and it is an old telescope. It's much older than all of you. It was built in the 1970s, and it's not even a very big telescope anymore. Its mirror is roughly 4 meters across, which sort of puts it in the second class of telescope. Now, the biggest mirrors these days, they're about 10 meters across, but this is still an excellent telescope, not only because of the mirror is really good, but because of the instruments that people have been able to put on the telescope. What you can see on the left here, this is an instrument called DECCAM, which is for an experiment called the Dark Energy Survey. So this is the Dark Energy Camera. And its job is to try and understand why it appears that our universe is accelerating. Why is the expansion of the universe getting faster and faster and faster? And this is something that we don't understand. And this telescope and this camera is observing the very distant universe to try and measure this stuff called dark energy, which is causing the universe to accelerate. Now, one of the things that it's doing as well as looking at the distant universe is, of course, it's looking at the nearby universe. And it's, again, trying to search for the signature of galactic cannibalism in our local environment, in the halo of the Milky Way galaxy. The picture here is, I know it looks kind of weird. It looks a little bit like a tank, But this is just basically the region of the sky that this telescope has surveyed. So again, this is much, much bigger than the size of the full moon. This is like a huge swathe of sky. So if you could see it imprinted on the sky, it would take up like a massive area of sky. What you can see in this image, if you look at the top here, this big, broad stuff, this again is the Sagittarius Dwarf Galaxies tidal stream that stretches across the entire sky, stretching over the survey by the dark energy camera. Down here at this bottom part, this is another dwarf galaxy which is orbiting our Milky Way. And this is one that if you're in the southern hemisphere, you can easily see. This is the Large Magellanic Cloud, which we know is also being disrupted and being pulled apart by our Milky Way. And eventually, the Large Magellanic Cloud will become even more food for the Milky Way. But if you look carefully in the rest of the image, whoops, wherever it's gone, if you look carefully in the rest of the image, you can see that there are lots of other little streaks which are scattered through this image. Some of them are harder to see, some of them are more obvious, which is showing that everywhere we look, we see that the Milky Way is surrounded by tidal streams of bits of food that are currently being consumed. So the Milky Way is growing by billions and billions of stars by consuming other galaxies that have strayed too close. Earlier this year, we started to get these kind of images. Again, this is a combination of these deep images, a big chunk of the northern sky, a big chunk of the southern sky, and the big band that you can see wrapping across here, that's the tidal stream from Sagittarius. But you can also see lots of other little bits and pieces, lots of streams and structures that tell us that our Milky Way galaxy is a cannibal. And we are actually doing a program here in Australia called S5, which stands for Southern Stellar Stream Spectroscopic Survey, which is a long name for a survey that we're doing with the Anglo-Australian telescope, which is located a few hundred kilometers from Sydney. And we are looking at these streams in detail. And what we've got on the left hand of this picture, this is a tidal stream that we've been looking at. It's in the constellation of Phoenix. And what we have seen is that there's this long, thin stream of stars which is stretching out across the sky. And we wanted to know, what is this stream made of? Where did it come from? What kind of object is being pulled apart by the Milky Way right now to give us this stream? So what we discovered is that the object that's being dismembered is unlike anything else that is in the halo of the Milky Way galaxy. It's unlike all of the other dwarf galaxies that we see. It's unlike the other globular clusters that we see. What we are seeing is that an object that must have been orbiting the Milky Way since almost the very beginning. In the first few billion years, it has been inside the halo of the Milky Way, but somehow it survived for a long, long time. But recently, it got itself into trouble. It's gotten so close to the Milky Way that it's now being dismembered. And we're seeing it just as it's being broken up completely. If we come back in about 1 billion years' time, which is short on the timescale of a galaxy, then this object will have completely disappeared and its stars will have been added to the stars of the Milky Way. So it's definitely true that the Milky Way is a cannibal. But the question is, of course, is the Milky Way alone? Is the Milky Way the only cannibal galaxy that we can see? And we can answer that question because there's a galaxy right next door. And this galaxy is the Andromeda Galaxy. And the Andromeda Galaxy is very photogenic. It likes being on posters. It's very pretty. Again, if we could get outside our Milky Way galaxy and look back, this is the kind of thing that we would see. But we were asking the question, is Andromeda also a cannibal? You can see that there are a few little galaxies nearby Andromeda. Is it eating smaller systems too? So we use this telescope down here. This is the Canada-France-Hawaii telescope located in Hawaii to basically look for the signs of galactic cannibalism in the vicinity of Andromeda. And this is what we saw. Now, we have had to zoom out here. That beautiful picture of Andromeda that we saw That's just in here. So what we're doing is we're looking at the outskirts of Andromeda, and the full moon would be about the size of this little blue dot here. This would be about the size of the full moon. So this is a huge area of sky that we've been able to look at all of the faint stuff. What kind of faint stuff is there? And are there signs that Andromeda is also a cannibal? And what you can see is surrounding Andromeda, there are streams and bits and pieces of galaxies that are also being consumed. So Andromeda is a cannibal. And you can see here, this is, at the top, there's a galaxy called NGC 147, because astronomers are really rubbish at naming things. And you can see it's got tidal streams because it too is being ripped apart by the gravity of Andromeda. And one day it too will be food for the Andromeda galaxy. And just to show you how big this is on the sky, this is an illustration that I made a few years ago, okay? This is what the sky would look like if your eyes were sensitive enough to see all of this sort of tidal debris in the vicinity of Andromeda, all the food that's being eaten right now. So again, in the middle, we've got the photogenic Andromeda galaxy. Here is the full moon. And then this is all of the debris, all of the stuff that is being eaten by Andromeda right now. And if your eyes were sensitive enough, it would cover a massive swathe of sky from horizon to horizon. So I just wish my eyes were 4 meters across so I would be able to see this kind of structure. So is that the end of the story, that we know that the Andromeda galaxy is a cannibal, the Milky Way is a cannibal, so most other galaxies must also be cannibals? Well, what we also know is that Andromeda is approaching us, and it's approaching us at roughly 500,000 kilometers every hour. So it gets closer and closer. So it's roughly 2 million light years away. So if you quickly do the maths in your head, blah, 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 in roughly 3 billion years, Andromeda will be here. So Andromeda, it clearly is going to be food for the Milky Way, right? It's another galaxy falling in, except remember, Andromeda is about the same size as the Milky Way galaxy. So what's going to happen when we have this major collision, when two big galaxies fall into each other rather than a big galaxy eating a small galaxy? So this is Andromeda and the Milky Way approaching, roughly 3 billion years. They're going to collide. Their gravities are going to grab hold of each other, but they're not going to, neither one is going to win this tussle. They end up starting to pull each other apart. So they will have a first collision, stars will get ripped off. There's a good chance that the sun will be ejected and thrown out into deep space, but then they'll keep colliding and colliding and colliding. So in this episode of Galactic Cannibalism, neither the cannibal wins, but they both sort of consume each other. And this is the future for in roughly 7 billion years. The Milky Way will be gone, Andromeda will be gone, and there will be one large featureless galaxy called Milkomeda. And I think I've used up my time, so I should probably finish there, and I would be happy to take any questions that you have about galactic cannibalism in the universe.